Welcome to the video on Introduction to Arduino. In this module, you will learn the basics of the Arduino platform, which will act as the microcontroller board for your project. In this video, you will be introduced to the Arduino technology. You will also know about the various Arduino controller-based Arduino boards, Arduino programming language, and the Arduino software for development and compilation. Arduino has evolved from being just an embedded environment to helping build advanced products for IoT applications, wearables, 3D printing, etc. Also, being an open-source platform, the hardware design schematics, PCB files, and the code for the software are freely available. This gives users the flexibility to adapt and develop the design for their own projects. Arduino is a combination of hardware with boards, kits, shields and accessories, and an integrated development environment. Arduino Uno is the most widely used microcontroller board, and the best board to get started with electronics and coding. Arduino Nano is an example of a smaller form factor of Arduino boards, called an Arduino module. Arduino LilyPad, and derivatives of it, are primarily used for developing wearable technology. Shields are elements that can be plugged onto standalone boards to add additional features to the board. As Arduino is an open-source platform, there are other alternatives available designed by electronics enthusiasts, drawing inspiration from the actual Arduino board designs. Arduino boards mostly use the Mega series of AVR microcontrollers, which were developed by Atmel. These are 8-bit microcontrollers, with on-chip flash memory. ATmega 168 and ATmega 328 are primarily used in the Arduino boards. The architecture of the Arduino board. In this video, you will learn about the architecture of the microcontroller on the Arduino, and the structure of the Arduino board. As you had learned earlier, Arduino boards mostly use the Mega series of AVR microcontrollers, developed by Atmel. These are 8-bit microcontrollers, with on-chip flash memory, for program storage. ATmega 8, ATmega 168, and ATmega 328, are primarily used in the Arduino boards. Let us also review some basics of the microcontroller you had learned. Microcontroller is a small computer on an integrated circuit, which performs a specific task, based on a pre-programmed instruction set. It has a processing core, memory, and input/output peripherals. The arithmetic logical unit performs all the necessary operations on the data, as suggested by the programmed instructions. The data memory holds the data, and the instruction set, or the programs necessary for the functioning of the microcontroller, are stored on the instruction memory. The input/output ports act as the interface between the microcontroller and any external peripherals for data exchange. The control unit is the central processing unit that determines the execution of the instruction set. You will now learn the architecture of the AVR microcontrollers in detail. The central processing unit is the most important component in any microcontroller. It consists of the ALU for the arithmetic and logical operations. General-purpose registers are small data storages into where the data is loaded from the main memory to perform operations. This is done to increase the speed of accessibility for necessary or repetitive data. The general-purpose registers are used to store both data and addresses of specific instructions. Interrupts are used to alert the microcontroller for some specific conditions, by saving and suspending the normal control flow, and executing a new set of high-priority instructions. These are an efficient method to make the microcontroller respond to any external status change, compared to cyclically checking the signals from external devices, continuously. The instruction control unit fetches instructions from memory, decodes it, executes it, and stores the result. The CPU is interfaced with the memory, the counters, and the I/O ports. The memory in any microcontroller is classified into volatile and non-volatile memory. The volatile memory stores information only as long as the device is powered. It is erased once the device turns off. The non-volatile memory can retrieve stored information even after it is powered on, following a switch off. The EEPROM is a type of non-volatile memory that is used to store small amounts of data, which can be retrieved even after a power cycle. EEPROM is used to store data such as device configuration and calibration tables. The data in the EEPROM can be accessed, erased, and rewritten. A larger in-memory size EEPROM is called the flash memory. The program that needs to be executed is usually stored in the flash memory. It is non-volatile, just like the EEPROM. The flash memory has faster accessibility compared to EEPROM. The static RAM is a volatile memory where data is stored temporarily before moving into respective registers. The data is erased as soon as the device powers off. This is primarily used to increase the speed of instruction execution. Timers and counters are very important components in a microcontroller. These set the frequency at which the instructions will be executed, interrupts are generated, and also the frequency of pulse-width modulation signals. The input/output ports are essential to interact with external peripherals. These are primarily 8-bit ports, with each bit corresponding to one I/O pin. The pins are digital in nature. Each pin can be referred to individually, or the whole port can be addressed as well. Each pin acts as either input or output, based on the programming. The analog ports are used to handle analog data. These are connected to an analog-digital converter that convert the analog signals to binary numbers that can be used for specific applications like PWM. Now that you understood the basics of the AVR microcontroller architecture, you will learn the pin structure of the 28-pin ATmega 328 microcontroller. Pins 9 and 10, and pins 14 to 19, correspond to port B. Pins 1 and pins 23 to 28 correspond to port C. Pins 2 to 6 and pins 11 to 13 correspond to port D. Pins 23 to 28, or the first 6 pins of port C, are the analog pins. All the pins of port D and the first 6 pins of port B are digital in nature. Pins 15 to 17 can be used for pulse-width modulation to operate servos. There are also pins for VCC, ground, reset, and clocks too. You will be using Arduino Uno for the project, as mentioned earlier. It works on the advanced RISC architecture, with 3 PWM channels, on-chip analog-digital converters, and external interrupt sources. The Arduino Uno has the ATmega 328 microcontroller. These are the TX, RX pins, for serial communication. The pins labeled with a tilde sign can be used for PWM to control servo motors. These are the digital I/O pins, and these are the analog pins. The 16 MHz crystal oscillator acts as a clock for the board. The USB to UART plug is used to interface the Arduino board with a computer, for loading the program onto the board, and also powering it, in the absence of an external power source. This is the external power supply, and this is the reset pin, needed to restart the execution of a preloaded program. You now know all the basics of Arduino and its architecture and structure.